So when you first see this looks like it's going to be the same type of problem. Here's the reaction, initial change, equilibrium. Let's just focus up here on the first set of data. And with 5 moles of oxygen, 4 moles of nitrogen monoxide entered into a 1 liter empty flask. So 5 moles of oxygen, 1 liter. 5 moles per 1 liter. Oh, that's 5 molar. How exciting. And then 4 moles per 1 liter, that's nitrogen monoxide, into an empty flask. So nitrogen dioxide doesn't exist in there yet. It's empty. And then I would set up the rest of my rice table, subtract 2x, subtract x, add 2x. At equilibrium, this would be 4 minus 2x. This would be 5 minus x. This would be 2x. Now my rice table's set up, and I haven't finished reading. Calculate the equilibrium constant. Whoa, we're solving for K. That is the question. If the amount of NO2 at equilibrium is 1.5. So at equilibrium, NO2 is 1.5 moles. It's in 1 liter, so that is the concentration, but it's at equilibrium. And where a lot of people make mistakes is where does this fit into the rice table? This is data that needs to go into this rice table. It's not the initial data. Initially, it was empty, so there was no NO2. It's at equilibrium. It's here at equilibrium. So the NO2 at equilibrium is 1.5. Wait, but Mr. Murphy, you say it's 2x. Exactly. This is a beautiful thing. 1.5 is equal to 2x. That's algebra that I can do in my head. If 1.5 is equal to 2x, then x is 0.75. X is 0.75 molar. Now, every x that's in the rice table can be filled in. Bam, 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 bam. The only thing that's missing is K. So they tell us the equilibrium value for something. We already have the equilibrium value written in terms of x from our rice table, and they collide together and help us solve for x. Rice, organize the data. Extra data there helps us figure out the equilibrium. This is a much more common AP question. This one's much more common than having to use the solver function to solve for x, because that can be a disaster, as you've probably realized at this point in your homework. These are a lot easier though, so you don't have 15 of these in your homework, you only have a couple, you have 2. The next one's kind of a similar idea. 2 moles of ammonia, 1 liter, 650. Equilibrium, only 71% of the original was found. Determine the equilibrium constant. So, well, let's just do the rice part first. Let's just use the initial data. There we go. 2 moles of ammonia in a 1 liter flask. It doesn't say there's any nitrogen and hydrogen, so you say those are 0 initially. So we have to be losing ammonia, gaining nitrogen, gaining hydrogen. Beautiful thing. And then it says, at equilibrium, 71% of the original NH3 was found. So, started off with 2 molar NH3, and we're going to have 71% of that. So that would be 1.42 molar, because 71% of 2 molar is 1.42. So this term here is equal to 1.42, and we can solve for x again. And here I have it written out like 2 minus 2x is equal to 2 times 71%, so x equals 0.29. Now that I know the value for x, I know all of these values for x. I can plug them in, plug them in, And then an unfortunate thing sometimes occurs right here with a lot of kids. They do all of this beautiful, we solve for x, plug it in. 3 times x is 0.87. Don't forget, when you go to k, that 3 here, that becomes an exponent, right? And then this 2 becomes an exponent when you solve for k. Those little unfortunate details can really just irritate you when you're doing such a good job working through such a hard problem, and then to miss that squared, it's just infuriating, makes people mad. All right. The next 2 questions are about Le Chatelier's principle. We're going to make that a separate video.